Chemical reactions, the first topic in chemical reaction, the speed of the reactions, and also we call it the reaction rate. And we will start by defining this concept. It means that the chemical reactions or the reaction rates, it's a change in concentrations of the reactant within the time. So as we go within the time, for example, if we have here the concentrations of the reactant, the concentration can change within the time. So either the concentrations decrease, it also can increase, and at certain point it stops. Why it stops? Because all the reaction will change to the product. For any change in concentration of the reactant within the time, we call it the reaction rate. So to understand the factor that affect the reaction rate, we first need to understand the collision theory. What's the collision theory? It's when the particles collide within each other, and the particle must have enough energy to react within each other. So in any chemical reactions, the particle will never react within each other. Either they have enough energy to react. So to understand the factors, we have to know that if we have A plus P in any chemical reaction, that gives me C plus D, for example, A and P must join, collide, react within each other, and they must have enough energy for the chemical reactions to give C and D, the product. So to understand the factors that affect the reactions, we need to understand this collision theory. The first factor is the concentrations, and to understand the concentration, it's as we know in any chemical reactions, as the concentration increase, the rate of the reaction increase, and we can check it here in the equation. Let's understand this more. Imagine that we have a tube. The first test tube, they have only 1 particles of A and 1 particles of P. In the second test tube, we have 3 particles of A, or 3 atoms of A and 3 atoms of P. At which test tube the rate will be higher? At the second test tube. Why? Because as the concentration increase, the particles are closer to each other, so it's easily for the particles to find each other's joins, collide, and they will use less energy for the collision theory to occur, or for the reactions to occur. In the first test tube, the particles with low concentrations, they are far away from each other, so they will take time for each particle to find each other and for the chemical reactions to occur. That's why as the concentration increase, the rate will increase. And the second factor is the temperature. When the temperature increase, the rate will increase. That's why let's understand temperature increase the kinetic energy of the molecule. When the kinetic energy is increased, movement of the particles will increase. So if the particle is moved faster, so it's easily for any particles to find the other particles to join with it, collide with it, or react with it. So when the temperature increases the movement of the particles, the collision theory will work faster, so the chemical reaction rate will increase. Pressure. The concept of pressure only works in case of gases. Let's understand it more. In the first test tube, for example, we have low pressure, and in the second one we have higher pressure. As the pressure decreases, the particles are closer to each other, so collision theory will work faster, so the reaction rate will increase. The catalyst increase the rate of the chemical reactions, and we have 2 types of catalysts. We have the chemical catalyst and the biological catalyst. How the catalyst work? The catalyst, it's a molecule that's help in the reactions. How it help in the reactions? For example, it's like this. The first particles like this, and the second particles is like this. What the catalyst do? The catalyst help in the joining of these two particles. They put them together and they give me the product. That's why they say here the catalyst remain chemically unchanged. That's why it also help in the increasing the rate of the chemical reactions. The catalyst, as it's increased, the chemical reaction rate will increase. The last factor is the particle size. So in case of particle size, let's see this paragraph here. In the first one, the size of the particle is large. So if this is one of the reactant, let's say for example this is P and A want to react with it, A can work in only this direction. For example, if we decrease the size of P, now A can work in many directions. If we increase it more, the direction for the A to work will increase. And if we make it powder, it's gonna be easily for A to work with B. That's why as we decrease the size of the particles, the speed of the reactions will increase. That's why the particle size is very important to be slow, that increasing the surface area, larger surface area, so the rate of the chemical reactions will increase. We have something called reaction with light. Some chemical reactions need light to work or for the chemical reactions to occur, and we have many reactions will also take only two, the reductions of silver halides and the photosynthesis. In case of reduction of silver halides, we will use a layer of silver bromide. For example, what will happen? The silver will accept electron from the bromide. It's a reduction reaction. When it accepts this electron from the bromide, it will change from white to black. So the layer of the silver halide will turn the layer that faces the light. For example, this is the light. So the layer that faces the light will change from white to black, and the other layer will be white. So here white, and here it will turn to black. White turn to the black because it reacts in the presence of light. The silver will take electrons from the bromide or from the halide and give me the black color. The other reactions is the photosynthesis, and in case of photosynthesis, it's the process by which the plant make their own foods, and here the plant in the presence of light will turn the carbon dioxide and water into glucose and oxygen. In the absence of light, these chemical reactions will never occur. In the presence of light, the product will be formed, and as the light is increased, the rate of the chemical reactions will increase. For any chemical reactions, to calculate the speed of the chemical reactions, we can use many methods. So here we will only take two methods. The first one is by calculating, in case of gas, by calculating the volume of the gas, by measuring the volume of the gas. How this occur? In this conical flask, for example, we'll put the product or the reactant here, for example, sodium chlorate. What will happen? The sodium chlorate will split to give me oxygen and sodium chloride. The oxygen will escape because it's a gas. What we will do? We will collect this gas and measure the gas. As the volume of the gas increases, this means the chemical reaction is happening and the speed of the chemical reaction is higher. So we can plot then a graph. We will put the volume of the oxygen and the time. We will see what? At first, the chemical reaction speed will be very high because we have many reactants, and then the speed of the chemical reaction will slowly decrease until we reach a point. At this point, the rate of the chemical reactions is equal 0 because all the reactant is used and all the reactant is turned into product. So at this point, the rate equals 0, and at this point, the rate is very high. The second method is by allowing the gas to escape. For example, in these reactions, when calcium carbonate react with hydrochloric acid to give me calcium chloride, carbon dioxide, and water. What the gas here is the carbon dioxide. So in this chemical reaction, we will allow the carbon dioxide to escape outside, and then we will start to calculate the mass of the reactant minute by minute. And then we can plot two types of graph. The first graph is by plotting the total mass at the beginning within the time. What will happen to the total mass? It will decrease gradually because all the reactant will turn to product. So at this point, the reactant or the rate of the chemical reactions is higher, and then it's gradually start to decrease until we reach a certain point. At this point, the chemical reactions rate will equal to 0. The second way is by plotting another type of graph using the loss of the mass within the time. And here it's the opposite. The loss of the mass will increase, and then start to decrease gradually until we reach a certain point at which the rate equals 0. So by plotting these two types of graph, we can understand how the rate of the chemical reactions is increased, how it's decreased, and at which point the rate of the chemical reactions stop.